Well, hey, good morning or good afternoon, everybody. So these are going to be the beginning notes on equilibrium. These should be put on the next blank page in your notebook. We'll update the table of contents when I'm back tomorrow. Let's see. So equilibrium. So I'm going to kind of break this down here. And for my substitute, after I talk about this, you can push the enter button on the dot cam and that'll momentarily pause it. So, part A under equilibrium notes. And the word equilibrium just means equal, and this means a change. Yeah, believe it or not. So some chemical reactions, this is my abbreviation for reactions, RXN, they can go forwards and backwards. So I've used these arrows. We've been used to this year writing our chemical equations with arrows to the right. But with these reactions, they can also go backwards. And these are called reversible. So pause here if you need a moment for the students to get those down. So for example, water can dissociate, break down, into hydrogen ion and into hydroxide ion. But what happens is those hydroxide and hydrogen ions, they will reform almost immediately and reform back into water. And sometimes the forward reaction going to the right is favored. Sometimes going back to the left reaction, the reverse reaction is favored. You won't get it until you're in AP chemistry or in college. There will be a certain ratio of hydrogen ions to hydroxide ions, and they call that, there's an equilibrium constant, and for water it is the K EQ, that's supposed to be a Q there, not a, sorry about that, not a G. EQ is 1 times 10 to the minus 14. And that's why when we're working with pHs, 14 is always the magic number. So we're going to move on now. So these reactions, once they get going, they're going to reach a point that they can go forwards and back at a steady rate. That means there's just as much of the product being made as there is the reactant being made. And once they reach this state, it's called equilibrium. And kind of think about when the bell rings at school. All of a sudden, this nice, steady, calm Buchanan campus gets flooded. Students are pouring out everywhere. This is not an equilibrium. More or less, we could say, okay, the reaction's going to the right. People are moving around. But then after about 10 or 15 minutes or so, when people get to class, pretty soon, the reaction, all the people walking around, the campus kind of goes back to the calm level. Only a few people walking around. And that can kind of be the reverse reaction, that now that the campus is at equilibrium, you've got a few people moving here and there. And you can kind of think of chemical reactions like that. When we stress the system, and we'll talk about that later, we can either force the reaction to the right or to the left. Just like the bell here at school, it can force kids out of the room momentarily. You got things happening, but then it calms down and there's just a nice steady rate of students moving around. With the chemical reactions, the gentle back and forth is the equilibrium, is when it's at equilibrium. Now, part B. And if you need to pause this sub, please do by pushing the enter button, and then you can push the enter button again to get it going. So part B, equilibrium shift. I'm using EQ to abbreviate equilibrium. Okay, so apparently there's a meeting in the lecture hall. So a stress to the reaction, and I put a little asterisk there. We'll talk about what the stresses are. A stress to a reaction at equilibrium will make the reaction favor either the products or the reactants. So one of the biggest ways is if we were to dump more hydrogen ions in, that would force the reaction to the left. If we were to dump a bunch of water in here, that would force the reaction to the right. You don't need to write, we'll get those later. So pause if you need to. Okay, and then just the definition, a right shift means that the products are favored. If the equilibrium shifts left, the reactants are favored. So you can write that down there. The next part is going to be Le Chatelier's principle. So he was a French chemist that, that worked out a lot of this stuff. That's where we're going to stop our notes today with Le Chatelier's principle. I think you're going to see that in the homework tonight, the vocabulary for chapter 18, section 2. It's only section 2. There's like 5 words, I think. And yes, draw diagrams. So with that, we'll call it a day here. And you can get your textbooks, and I'd like you to get working. You might have to share textbooks at the table, help each other out. And bring your stuff for Quesadilla Tuesday. Bye.